Alright, so I'm going to go define the forces we'll be using in this class. So let me go through all these forces with y'all. The first one is just the basic if two objects are touching each other. So think of the block on the table. There's some sort of interaction occurring between the block and the table. I'm going to call that a normal force. Alright, so the direction of a normal force. This is probably going to be the most common force outside of another one you could probably think of. It is, what this symbol means is perpendicular, and I'll kind of rewrite this. Let me zoom in. So, perpendicular to the contact surface. And I'll draw perpendicular. So that's a symbol in geometry, that's what you would see. So this block, basically the block pushes into the table, so the table pushes back up with the equal and opposite normal force. And I'm going to take this time actually to explain a very important law. So Newton came up with 3 laws. So Newton's laws of motions. And Newton's third law, you might be thinking, why are we starting with the third law? Trust me, it's better to start this way. Every action has an equal and opposite reaction. Alright, so what does that mean for us? Think of this as every force has an equal and opposite force. And when I say equal and opposite, that's a directional thing. So equals the magnitude is the same, opposite reaction, that's like it going the other way. The block pushes down, the table pushes back up. We'll talk about this more later. When is it present? When two objects touch each other. If there's contact. Now, the symbol's Fn. And for the equation, I'm just going to put like this little dash here. Don't worry about it. No equation for now. And you'll find with a lot of these forces, we're not gonna fall to an equation, if that makes sense. We're gonna have to use another method, at least at this point in time. So my normal force here, you can basically call if two objects touch each other, everything could be a normal force. The only reason why we're gonna specify forces later on is because if we don't, then essentially everything's called a normal force and it's confusing. So we make more names for forces to make it easier for us to interact with stuff. So, alright, normal force. Let me go back to my interactions lab and let me think of other things I may have seen. So we talked about, alright, the table, the block, they push each other. Okay, that compression, normal. Some people might say weight, it would be next. I'm going to put in weight later. Oh, look at this block in the ramp. If you remember, we said, oh, there is a shearing interaction. So that shearing interaction, I'm going to, where am I going? I'm going to go back here, and I'm going to say there is a friction force. It's parallel to the contact surface. When you rub your hands together, it gets warm because of friction. That's what friction is. Everyone knows what friction is. So when objects slide by each other, the symbol, notice all my forces, it's big F and then another symbol, small f. I'm going to skip the equation again, and most of these I'm going to skip in this unit. We'll come back. I'll give you equations later in the next unit, but most of these we're not going to have an equation for. All right, so friction is there. All right, the next one, if you remember that rubber band, a rubber band's actually a spring. So whenever a spring is stretched or compressed, that's when you have it. And actually, sorry, this should be over here. And the direction of the spring, it's along the spring. I'm just going to keep this here just so I don't have to erase everything or drag stuff around, but switch these. It's along the spring is the direction of it. It's whenever a spring is stretched or compressed. The symbol is big F, little s. I'll give you this one. Fs is equal to K times X. K is a spring constant. X is how much it compresses. We'll explain that later. when the two strings are holding up an object, we'll call that tension. It's along the rope, and tension is caused by ropes, strings, something along that, cables, cords. And so whenever a rope, cable, cord, anything like that, chains, etc., is taut. So when we say taut, imagine the rope is tight. That's what taut would be. All right, we're doing good on time. I'm going to use big F, big T to describe that. No equation again. I know. It's probably annoying. All right. If I were to push an object, like as a person, I'll call that applied. Now, all applied is, it's, whatever direction a person pushes or pulls. Some people teach applied, some people don't. I don't want it to be too confusing. It's a normal force caused by a person. That's what I want you to think of it. But usually there's some sentience. We'll talk about that later. But it's just another force we can put on there, so we don't have to call it force normal 2 or 3. When we do a lot of calculations, that's what we'll have. So applied, it's present, person pushing or pulling. I call it FA, big F, big A, and no equation for it. We've gone through 5 of these forces, and yet the most common one that most people think of has not been put here. And I separated out for a reason. You may have guessed it's gravity. Sometimes we call gravity weight. So your weight is the force of gravity, and we'll talk about that. The direction is down, simple enough, and I'll put in parentheses center of Earth. That is what's trying to cause gravity. What is causing gravity is basically the mass of the Earth pulling down on us. It's present, I'll just say anywhere on Earth. Anywhere on Earth. I'm just going to keep it simple. The symbol's F sub G, so big F, little g. Sometimes you'll see it as big W. The formula is the same for both of them. It's just Fg is equal to mg. So both of them would be the same. So these are our forces. I'm going to refer to these 6 forces over and over again. Hopefully y'all will start, I'm not going to say memorize, but hopefully you can recognize when we're talking about it. I don't think it's too hard to memorize. You already know friction, gravity, you know springs. Need to know ropes or tension, applied as a person, and normal is just any inanimate object. All right, I'm going to stop it here, and then we are going to go work on some of the new diagrams that are going to come up in this unit.